Hi everyone, hope everyone's doing well on this Friday of the Dakota Bowl. Today I'm going to finish up with that oxidation numbers that we didn't finish up with yesterday. So we're going to look at this first question, number 14. So make sure that you have the oxidation numbers sheet out from yesterday. And we are going to get right into it. First off, remember we talked about cations earlier. Cations are positive. Remember the pause that I put up on the whiteboard to help you guys remember. So obviously, if cations are positive, anions are going to be negative. So when we look at filling in the oxidation numbers of these elements, we look at bromine first. Bromine is in group 7A, the halogens. So that means it has 7 valence electrons. So looking at it, would it be easier to gain an electron to get an 8 or lose 7 electrons? And obviously, it would be easier to gain an electron to get that full 8. So bromine's oxidation level will be Br, and then you can put a little -1. Now I'm not going to do this for you, but you can put the -1 a little bit above the R and smaller as I put on the board. It's hard to do that on Word, and I'm not going to take the time to do that. And I'll show it to you when I get back. But anyways, chlorine is the same way. It's a halogen in group 7A with the valence, with the halogen, so the 7 valence electrons. So Cl, oxidation number of -1. Fluorine, another halogen, most reactive element. Again, -1. Iodine, same thing, -1 as its oxidation number. If we go to phosphorus, phosphorus is in group 5A, the nitrogen family. So phosphorus is going to have an oxidation number of -3 because it needs 3 electrons. So it's gaining 3 negatives to complete that orbital shell. So we look at nitrogen, same thing. It needs 3 electrons for that orbital shell. Oxygen. Oxygen is in group 6A, the oxygen family, so it's going to need 2 electrons. So it's gaining 2 electrons. Oxidation number is -2. Sulfur, same thing. Oxidation number is -2 because it's in the oxygen family, group 6A. It needs 2 electrons. So now that we finished 14, let's go to the conclusion questions here. First off, with what is the name or another name for a positive ion? I talked about this at the beginning of this segment. Yes, you are correct. A cation. Remember yesterday we said I had that picture of the cat ion and then it's pos or positive. So cation. Why do positive ions form? The reason positive ions form is because elements lose electrons. They're losing negativity. So if you lose negativity, you're going to become positive. Hopefully you guys can lose your negativity for the rest of the year and just be a proton, be positive. All right, number 3. What will form a positive ion? Metals or nonmetals? This is going to be metals. Metals form positive ions. We'll get into that later about why that happens. Looking at number 4, what is another name for a negative ion? That's what we just talked about up here, and that is an anion. Why do negatives form? Well, just the opposite. Instead of losing electrons, elements gain electrons. They're gaining negativity. They're becoming negative. So what will form a negative ion? Well, that's just the opposite. Those are the nonmetals. So essentially, metals that form positive ions, the cations, are groups 1A, 2A, and 3A. Then you have on the other side, forming anions are the nonmetals, group 5A, 6A, and 7A. Let's go down to number 7 here. So some metals have more than one oxidation number. These are usually your transition metals. The oxidation number is written in parentheses as Roman numerals to tell you the charge. There's a list of these on the back of your periodic table. So make sure, and again, if you don't have yours, just grab one up from lab table number 1, the laminated copies. But the back of that shows the oxidation numbers of all of these elements. So I'll do a couple here. Silver, which is Ag, is +1. And again, this +1 can be written smaller above the G and to the right, like right there, that area. Nickel, that's Ni, and that's going to be +2. Zinc, Zn, +2. Nickel 3. Now, see how the Roman numerals that tell you the oxidation numbers? All right, so I just had a call there. I had to pause that for a second. So with nickel, Roman numeral has 3. So Ni +3. And that's just what that oxidation number tells you. The only one that's tricky is lead. If you don't know Roman numerals, V means 5. If it's on the left side, you have to subtract 1. So this is lead 4. So lead 4 is going to have an oxidation number of 4. So +4. That's Roman numeral 4. The rest of them you can look up on the back of your periodic table. Same thing with this. Sometimes atoms of different elements are found together so often we have given them actual names. We call these polyatomic ions. So each polyatomic ion has its own oxidation number, therefore they are not compounds. So again, use the chart on the back of your periodic table to fill in the oxidation numbers. And this concludes our lesson for oxidation numbers. I am going to do another video lesson here on our next 2 lessons with ionic and covalent bonds, as well as the dot diagrams for you today. Keep in mind, you have a quiz on Monday on ionic and covalent bonds, as well as the dot diagrams and what we are doing today.